Hello, my dear student. Today we will start the chapter Motion from class ninth. Let's start motion. First, we discuss the terms, the important terms, and the first term is a distance. So, first of all, what is a distance? As we know, any body starting from the initial point, that the initial point is called a reference point and the end point is called a final point. The distance covered or the path covered between initial point to final point is called distance. As we know, the distance has only magnitude, hence distance is called a scalar quantity. So what is a scalar quantity? Scalar quantity is a quantity which have only magnitude but not direction. This quantity is called a scalar quantity. Now the second term is a displacement. So what is a displacement? The displacement is a shorter distance covered or shortest path covered between reference point or initial point to end point or final point. That is called a displacement. The displacement is a vector quantity because they have magnitude and as well as direction. Hence displacement is a vector quantity. Now the second term is a motion. The motion is the distance covered by an object with respect to time. This is a motion. The motion are in two types: uniform motion and non-uniform motion. So what is a uniform motion? Uniform motion means the distance, equal distance travel in equal time interval. So this is a uniform motion, and the non-uniform motions are those motion which have non-equal distance covered with a equal time interval. This is a non-uniform motion. Similarly, the next term is a speed. The speed is also be a scalar quantity because in the case of the speed they have only magnitude not direction, hence speed is a scalar quantity, and the speed is mathematically written as speed is s. This is a denoted by s. S is equals to total distance upon total time taken. So this is a speed. Now the second term is a velocity. So what is a velocity? The velocity is a displacement upon time. The displacement is a vector quantity, hence velocity is also be a vector quantity. The velocity is categorized in the two form: initial velocity and the final velocity. Initial velocity is denoted by small u and the final velocity is denoted by small v. And next term is a acceleration. What is a acceleration? Acceleration is a change in velocity with respect to time. So that is a final velocity minus initial velocity upon time taken. Mathematically it is written as a is denoted by acceleration denoted by a. The a is equals to v minus u upon small t. Small t, where small t shows the time taken. Now all these, with the help of these terms, we will going to study the graph. So let's start the graph. The first graph is a distance time graph. In the case of the distance time graph, here I have the graph. There are the two axes, the time axis and the distance axis. In the time and distance axis, here the 2 point is there on y axis. This is a to b. We are moving a to b. The a to b, the distance is not changed but the time is changing. It means the object is at rest, object is not moving but time is regularly going on. In this case the slope is 0. That if the slope is 0, we can say the body is at rest. In the second graph, here for a body moving with a uniform speed, here uniform speed, the x-axis shows the time and the y-axis showing the distance. The object starting from the origin to reaches point A, they are the change in distance with respect to time. So they are the equal distance travel with a equal time interval, hence this is a uniform speed. Now for accelerated motion, as we know the term is accelerated. Accelerated means suddenly increasing velocity, sorry, motion, suddenly increasing motion. In this case the graph, the slope is increasing in order. Here the graph is showing initially the graph is growing slowly, and but after that they are growing in fast in manner. Here fast in manner, that means the slope is very high. Let us here, the slope is very high, and if the slope is high, that means we can say this is a accelerated motion. Accelerated motion means the they are moving, initially moving is slow, but after some time its speed is increasing. Now deaccelerated or speeding down motion. Deaccelerated or speeding down motion means the body is start with a high speed, but after that they are going to decrease. The example, with the help of the example I uh, told you, when we apply a brake in a car or the motorbike, the speed is decreasing. Hence this is a deaccelerated motion. In this case the slope of the graph is decreasing. Now we start with a velocity time graph. Here in the first case, in the x-axis the time is there, and the y-axis velocity is there. So in x-axis and y-axis we seen the object move with velocity a to b. Here in the position a the velocity is initial, and at point b the velocity is final. The a to b, here the final velocity minus initial velocity, the final velocity minus initial velocity is equals to 0. If the velocity is comes 0, the change in velocity comes 0, that means acceleration is 0. Why? Because acceleration is a change in velocity. Here change in velocity is 0, since its acceleration is 0. Now in the second case, here when a body start from the rest, that means rest, this is the initial velocity, and initial velocity is 0 with uniform acceleration. Here the acceleration is positive in nature. Why? Because u is smaller as compared to final velocity. That means the final velocity is increasing, but the initial velocity is 0. Hence the results comes out change in velocity is in positive. The results comes out change in velocity is in positive in manner. If the value comes in positive in manner, hence we can say this is a increasing or accelerated motion or velocity. Now in the second case, here the body is starting from a to b, but here initial velocity is not 0, but from a to b the velocity is regularly increasing. It is also called a uniform acceleration with not initial velocity is 0. Now in the second case, here the slope is increasing. If the slope is increasing, it means the velocity is increasing, the increasing acceleration. In the next graph, here velocity time graph, here the velocity is going initially increasing, but after some time they are going to decreasing. So this is a case. Let us start. This is the first case from here to here. This is a car started from rest to its maximum speed, and after applying a brake it's going to decreasing. If it is going to decrease, and this is a increasing any acceleration, and this case is a deacceleration. The deacceleration, in case of the deacceleration, the negative value slope is comes out. That means deacceleration is also called a retardation. The retardation is a negative acceleration. Now here when a body is moving with a uniform retardation and its initial velocity is not 0. Why? Because it is a retardation, and we know that in the case of the retardation the initial velocity is high and the final velocity is low, and the change is negative. If the change is negative, that means this is called a retardation. This graph is showing you the velocity time graph. This is a angle is greater than 90 degree, that the slope is negative. The slope is negative. Now the few definitions are there, we have already discussed in the initial of this class. Now we are going to start. The term is a average speed. What is the average speed? The average speed is a total distance. Let us consider I have a non-uniform motion, so there is a not uniformly body uniformly moving, so there are the two different motions are there. The hence, so we can say the average speed is a total distance covered by an object with total time taken. So this is a average speed. Now average velocity. So what is average velocity? The average velocity is a velocity, initial velocity, and the sum of initial and the final velocity is mean. If we find the mean of the velocity between initial and the final, this is a average velocity, and mathematically it is written as here v average is equals to u plus v divided by 2. Here u is equal to initial velocity and v is equals to final velocity. Now acceleration, we have already discussed. Acceleration is a change in velocity with respect to time. So here this is a stands for the acceleration, v minus u upon t, and the SI unit is a meter per second square. So how it's come meter per second square? So as we know, the velocity is a distance upon displacement upon time. The unit of the displacement is meter and the time is second. So meter upon second and also divided by the second, it means meter per second comes. Now so this is today's and our lecture, and in the next lecture we are going to discuss graphical representation of the motion, and with the help of this graphical representation we will find the equations of the motions. So we know that there are the three equations are there. The first motion equation is v is equals to u plus at, second is equals to s is equals to ut plus half at square, and the third is equals to v square is equals to u square plus 2as. In the next class we will derive it with the help of the graph. And in this class you have any doubt related to this topic motion, you have any doubt, then you ask me, and the channel is you write down our question in comment box, you write down, and you need help to other topics, then you write down, sir please discuss the other topics, then I will pick up and make a video for your career point of view. And in this lecture you have any doubt, then you ask me in a comment box, I will damn sure give you the answer. Now thank you so much, and in the next class we will start next. Okay, thank you.